Hi guys, so we're going to do a video on the Feynman diagram, or quantum electrodynamics. Dr. Richard Feynman was a famous American physicist who contributed a lot to modern physics, but namely the Feynman diagram. So the Feynman diagram is a picture that takes all the really complicated math used for finding the behavior and reactions with particles around other particles and putting it into the very simple picture. So a Feynman diagram could look like this. Very simple, right? So what the Feynman diagram is, what this diagram specifically is made of is essentially just two electrons. One transmits a photon to the other, and they repel each other. So let's dive deeper into that. So here the first thing you should know is what the lines mean, right? Why didn't I just draw normal lines? So what the lines mean are, so lines like this straight line with an arrow inside it would be all the fermions. So the quarks, up, down, charm, strange, top, bottom, and the leptons, electron, muon, tau, and the neutrino versions of those. So that's what essentially this would mean. So we have the electrons, right, are going to look like this. Now the squiggly line is a photon, so it's going to be represented with a Y. And so that's essentially what the photon will be represented with. And then there's the line that looks like this. So I haven't used it here, but it looks like this. Is going to be either the W, Z, or H, the Higgs boson. So the W, the WZ or Higgs boson. So that's what it's going to look like. And then the last line is going to be a little spiral. That's going to be the glue line. Essentially, this is all the lines that are required to make one. So this is the first part. The second part we're gonna use is the standard model. So basically, all the particles in there. You probably already know. So just the quarks, electrons, the gauge bosons, and the scalar boson, Higgs boson. So here, right? And then there's another part, the third part. So, the building blocks. So the building blocks of a Feynman diagram, are essentially, they're called vertices. So a vertice is gonna look like this. Let's see, here we have, 3 parts. So we're gonna have 3 particles interacting with each other in space and time. So we have time going this way and space going this way, right? So it's just an electron, a photon, and being an electron again. So in this case, right, a vertice is going to look like this. That's going to be what it is, an electron emitting a photon. But if we were to rotate that, so then it would look like this. And also, we cannot go backwards in time unless you're an antimatter particle. So this would mean the electron is now an antimatter electron. So this now shows the process of 2 electrons, an antimatter and a matter, colliding and emitting a photon. Notice how the arrow is still pointing this way because it's an antimatter, so everything is reversed except the mass. So vertices are just the building blocks. So there are also more complicated ones involving quarks, right, that kind of stuff. So, but most the common ones are just very simple. That is all there is to the building of Feynman diagram. Now we have the conservation laws, the last concept. These are essentially just the rules with the field interactions. So, like, if we have, say, the electromagnetic field, which has all of the quarks, and it has the electron, muon, tau, and the weak boson, W boson, then all of those particles the rules are gonna be with the electromagnetic force. So here, right? So they're gonna have parity, strangeness, energy, time reversal, right? That kind of stuff. So those are essentially the rules for each particle in the field, as you can see here. So that now that we have all of that done, the last part is why are Feynman diagrams, like, what are they for? Why are they made? Well, Feynman diagrams were made to they're made to take, you know, all not to measure, but to think of how the particles near each other behave and how they interact. Like, so like particles like this, how they behave like this, right? And how they interact, how they move, that kind of stuff. So essentially that's all there is to a Feynman diagram. Thank you. Bye.